Oh, good afternoon, everyone. Can you all hear me clearly, right? Okay, so I want to welcome you to my lecture today. Before I get started, I actually received, kind of a feedback from student about some questions that are not visible in assignment two. I apologize for that. I've already fixed that now. And of course, because of that, I'm going to add 24 hours to the deadline for submission of the assignment. Okay, so you can check now. I've already, it should be visible now. Okay, so I want to welcome you to another statistical topic. Of course, statistics is like a story that goes on and on and on. So today we're going to be focusing on a new um, topic called sampling distribution related to normal. And of course, in the outline, I'm going to have a recap on the law of large number. Why am I going to have a recap on the law of large number is because there's a connection between the law of large number, the Chebyshev rule, and empirical rule. Then from there, I'm going to go into sampling distribution related to normal. Okay, so let me first start with the law of large number. Of course, if you take a look at what I'm presenting now, the other time I told you, uh, when we have a random variable y1 up to yn, okay, that we actually choose from population. Of course, this random variable maybe uh, maybe the annual average household income in a particular country, could be the proportion of the citizen that approve the job the president is doing. It could be the proportion of citizen having a certain disease and so on like that. Okay, now we believe that this random variable has mean or also has variance. And of course, when the mean exists, when the variance exists, the standard deviation is going to exist. Of course, the standard deviation is the square root of variance. Now, the sample mean that we call y bar is actually going to be a random variable, because if 1,000 researchers should go into uh, the population of interest, choose the same sample size, you're actually going to get different values for mean. Because of that, sample mean becomes a random variable. Okay, when the sample mean becomes a random variable, don't forget, we also have a target value. What is a target value? That is a population mean. Now, what we need to do, and I told you the other time, the population mean, the only way you can get population mean directly is when you study every element in the population. We do not have resources for that. So, which means there's no way we're going to get the population mean, okay, which is this guy. There's no way we're going to get that guy directly. What we're going to end up in getting, because we're going to be taking sample, is the sample mean. And of course, we need to be able to evaluate what we got, to look to see whether the distance between what we got and what we're anticipating to get is within a certain threshold that we call epsilon. And what the law of large number is talking about is that when I take a sufficiently large sample, and that is the reason why you see limit n tends to infinity. Every notation, every equation, they actually, saying something. So that guy is trying to say, when the sample size is sufficiently large, the probability of that the convergence is going to take place between the sample mean and the population mean, and that very convergence is going to be within a certain threshold, is going to be equal to 1. Now, we call this probability convergence. Okay, this is probability convergence because we got different type of convergence. Okay, but the one we're talking about here is what we call probability convergence, that we also call weak law of large number, because there's also a strong law of large number. The strong law of large number talk about convergence surely, convergence everywhere. But this one based on probability convergence, because we are actually talking about convergence within a threshold. Okay, now the other time on Friday, we proved that mathematically as n tends to infinity. And of course, we're able to see that that probability of the convergence within a threshold of epsilon is actually equal to 1. Now, I want to revisit this law of large number because, a student approached me from Austria because I posted a video on Canvas, on YouTube. Another student also, uh, you know, uh, send a message from Africa, and the person said that, okay, law of large number I mentioned is applicable in casino. Reason why casino is in business, applicable in insurance, applicable in renewable energy. And the person said, what about healthcare? What about engineering? What about maybe when government wants to actually measure the impact of their policy? Let me tell you this. The law of large number is applicable everywhere where they needed to take a large number of participants, okay, for them to be able to see how what they target, okay, we converge, okay. See how what they observe, we converge to what they target. I'm going to give you an example in election polling. I'm going to first start in election polling. There's something that we call exit poll. Has anybody heard about exit poll? The exit poll is conducted, you've heard about it, right? When election is going on, right? Okay, a poll conduct, not the one before election, when a good number of voters, they've already voted, okay? And, in a situation where you sample the opinion, across, race, okay, across, demographic, of course, at the end of the day, which means before you can do that, okay, you must have sampled a good number of voters. And that is the reason why at times when you watch CNN, when you watch Fox News, when you watch MSBC, you actually go, even when the election is going on, they're going to make a projection. They're going to say, it is projected that somebody is going to win, even the election is going on. So they rely on the law of large number to be able to do that. Does that make sense? Okay. Now, I talk about election polling. What about if I want to make a prediction of economic indicators in the future? Okay, I want to see how the inflation rate is going to be in the future. I want to see how the GDP is going to be. I think in the last quarter, United States are like, I think a 3.3% increase in the economy, in the GDP. Okay, if I want to see what the picture is going to look like in the future, if a good number, if a large number, look at a large number of economic data is involved, okay, that we hate what I call accurate prediction, a prediction you can rely on, because the more sample we take, the more we are very close to the truth. Does that make sense? That is in election polling. What about in public opinion survey? In public opinion survey, particularly in the United States, where the issue of abortion, or some are pro-life, some are this, they can they conduct opinion poll where they actually going to see, they do that with a large number, not just with a sample, not just with a small sample. A small sample may not reflect the overall view in the population. So the idea of the correctness of public survey rely on the law of large number. Now I also want to go into policy impact assessment. Okay, let's say government initiate and implement a policy, Okay, and the government really want to know the impact of the policy. If for government to know the impact of the policy, of course, they actually need to sample a good, a large numbers of participants. Not only they are not going to restrict themselves to a particular demographic, it's going to be across demographic, because they're actually going to give them opportunity to be able to see, whether the impact is actually felt, across demographic. What I'm trying to say, for policy assessment, the government actually normally rely on the law of large number. And before I go into another example, I'm actually going to say it's also applicable in healthcare. If I want to talk about drug efficacy study, you remember there was a paper published in New England Journal of Medicine around December 10, 2010, before December 10, 2020, there was lockdown due to COVID. The social interaction was restricted. In fact, as at that time, it looked as if the life was like no meaning, because you can't hug your loved ones, you can't do this, you can't do that. And, Pfizer actually, in the article that I mentioned that was published, they claim efficacy for a vaccine, that can actually prevent COVID. And let me tell you this, they actually participant into two groups, okay? Well, they actually vaccinate a group, and they did not vaccinate a group, and because they use a large numbers of individuals. I remember then in the control group, they have about 40,000. That's a large sample. In experimental group, they have more than 40,000. And of course, in the experimental group, they actually vaccinate them. In the control group, they did not vaccinate them. Those ones receive placebo, and they expose them to COVID, and they're able to determine the probability that their vaccine will prevent COVID. So which means the law of large number will actually ensure that, the average effect, the observed average effect will converge to the true average effect. There's a true average effect they have in mind, which I'm going to call the mean, the population mean. The observed average effect is the sample mean, but they need a good number of participants for them to be able to know. Now, I'm also going to say this lastly, there's something that we call side effects. If you really, when you develop a new drug, okay, for you to be able to observe side effect, then it means you have used a good numbers of individuals. Because when you use a small sample, okay, you may not be able to observe side effects. And that is good for what? For drug efficacy, for safety. Okay, so I need you to take note of that. Then there's another one that strikes me. Follow-up study. I don't know, you've heard about cohort study, where individuals are monitored. Maybe they are currently exposed. Maybe some of them are smoking, some of them are not smoking, and you want to see what is going to come up after, whether they're going to develop certain health condition. And let me also tell you this. When you talk about rare events, one of the disadvantage of cohort study is when we talk about rare event, like you want to talk about the probability of having heart attack occur in a blue moon. If you want to observe that effect, then you need a large number of participants need to be enrolled. Now you can see across field, now the law of large number is applicable. Now what is new today? What is new today is sampling related to normal. I want to go mathematical now. Okay, we want to focus now. We're focusing on the probability distribution that we call normal. I told you the other time, because of the shape of a normal distribution, okay, it's actually make it more flexible to some given situations. Now, if I have a random variable, y, okay, I got a random variable y, okay, the random variable y actually follow normal distribution. Take a look at this. That's what I mean. Y follow normal distribution with the mean mu, with the variance, where mu lies in real number, and the standard deviation has to be positive, greater than 0. Okay, let's say, for instance,